现在将录制本次会议。
I see they already started the recording, but we're still waiting for people to join. Okay, so today I was going to do case studies and also talk about some success stories, but I thought maybe it might be more applicable for us to talk about SmartOne, which is our unified communication solution. And the reason why I specifically want to present on this today is because basically all we've been covering, basically from analog to digital, the benefits of digital. We've been speaking about our body-worn cameras, our tetras, our trunking, and I think the SmartOne is a very good solution to discuss today, is because the SmartOne essentially brings all of these different technologies together to form a unified communication solution. So I think let's maybe start. The other people can also listen to the recording afterwards. Okay, so if we look at technologies and how they've evolved over the last few years, we can see that MPT was introduced back in 1988. Prior to that, you would get conventional analog, and then Tetra was introduced back in 1995. Tier 2 and Tier 1 for DMR started releasing from 2005. Tier 3 was introduced in 2009. And now from 2016 onwards, LTE, meaning push to talk, and all those type of technologies have started to become more popular as well. So one of the biggest challenges have always been, how do you interconnect these different systems to be able to communicate to each other? And this has been a big challenge for a lot of customers, especially if they invested in, let's say, an MPT network, and they are they've implemented a Tetra or a DMR system in a different location, and sometimes they want to be able to communicate across these different systems. So this has always been a big challenge, and normally how one would address these type of problems is to do what we call back-to-back, where you would basically connect one radio on the one end, which could either be a DMR or Tetra radio, and on the other side a DMR or Tetra or MPT. And the disadvantage with this is that for every group that you have on the one system that you want to talk to the other side, you would have to replicate this for every single group. So if, let's say, you have a group in the DMR system and you wanted to talk to a group in the Tetra system, you would have to have a dedicated radio for the one and a dedicated radio for the other group for them to be interconnected. So if, let's say, there's a different group in the one side and a different group on the other side, you have to replicate that again, put a second radio for both sides for them to have the interconnection. So this has always been a problem, because let's say if there's 10 groups in one system that needs to be connected to 10 groups in a different system, you would replicate this 10 radios on the one end, 10 radios on the other end for you to have the interconnection. So it's not a very cost-effective or very easy solution to do, because you have to, for every group, you have to pay for hardware to be, and also needs to be installed and so on. Okay, so for example, let's say you've got dispatching capabilities on the one system and you want to also have that same dispatching capabilities to a different system. This was also not an option before, because every dispatching software was developed for that specific technology. For example, if we had to compare it, let's say Smart Dispatch is for a conventional Tier 2 system. But let's say if you wanted to talk from Smart Dispatch to a different system, it was not possible, because Smart Dispatch was never designed or developed to work with a Tetra system or a MPT system. And then also one of the other requirements, which has been becoming more and more popular, is for people to have not just narrowband technologies, but also connected to the external or public networks, such as the telecoms or the public domain, for you to have interconnection between public and private. Also CCTV and those type of information, like video feeds coming from CCTV fixed cameras, all of that also to be available on the same dispatching platform. And then also in some instances, there's also requirements for the dispatcher to be able to access the internet, or let's say if a dispatcher had to receive an emergency call and they needed to find out information, being able to, from the same dispatching software, being able to Google something, to find information or intel, that's also now possible. And then also the GPS positioning for you to be able to see exactly where each and every radio is in the network and to be able to locate and track them. This has also been a requirement for many years from a lot of customers. Okay, so this is where the SmartOne was introduced and developed by Hytera. So you'll see there's different layers. So at the top layer, this is your client, which is for the dispatcher that would log into the system and have access to these different networks. You'll see the second layer is the service. This is your SmartOne server, your GPS positioning server, your voice recording if you want to have voice recording, your media switches for you to interface your CCTV footages and all that to be able to be viewed from the client. And then also the application servers if you wanted to run other applications, for example, monitoring certain equipment, all of that. And this all this basically allows for you to have this information from a single dispatching perspective. So you'll see there's two types of ways you can connect a system to SmartOne. So if the system that's running here is a Hytera system, we can connect to the system on an IP level, meaning you don't have to have a physical radio like on this side. You connect to it on IP and you have voice, data, all the information through this IP connection. If the system that you are going to be connecting to is a non-Hytera third-party system, for example, let's say if it was a Tetra system and it's from a different OEM, because we don't have the information or the API information for us to integrate or interconnect to the system on IP, we would use what we call a wireless gateway, and the wireless gateway will then have a physical mobile radio connected to it, and this mobile radio will then communicate and collect information over the air. Okay, so there's two ways. If it's a Hytera system, you can connect it directly with IP. If it's a non-Hytera system, you can use our wireless gateway. This wireless gateway is connected via IP connection back to the server, and this then can control this radio and what it needs to do over the air into that system. Okay, is there any questions anyone has? Just gonna continue. Okay. Right, so you'll see we've got two types of gateways. So we've got what we call a two-way gateway. So it's a small compact gateway that can support two mobile radios. And then we also have a 12-path wireless gateway. This 12-way can support 8 radios. So you can have a MPT radio connected to it. You can have a DMR radio, HF or air band or mid band. Any type of radio that has an interface for us to be able to interface to it can be connected to this gateway, and you can then from the SmartOne dispatcher have access to this radio and be able to communicate out into that network. Also, every single conversation that takes place on the network will be received by this radio, and it will also then record the conversations and everything onto the SmartOne server as well. And then we can also connect a PSTN gateway to this SmartOne, which will then give you access to the public network. This will allow for you to be able to make a phone call from the dispatcher to a cell phone or to a fixed line. And you can also, when receiving calls from outside of the organization, the dispatcher can then communicate to these, like if it's a cell phone, and they can also then dispatch this call through to a radio in the radio network. And then if we look at the central services, so we've got the SmartOne service, which is for you where all the information comes together. Your GPS positioning is a separate portion of the software where it will then record all the GPS positions. And then your voice recording, normally this would be a dedicated separate server where it will run the recording service. So this will record every single conversation. It will also record all the messaging between radios that are digital, that are sending text messages. It will record those information as well. And it will also record when a radio is switched on and when it's switched off as well. So you can also see when a radio registered to the system and then when it was switched off. And then also the media switches. This is if you're going to be connecting CCTV or those type of technologies to the system. You would then run that through the media switch. And then from the application level, this is if you want to either have third-party applications coming into the software, or if you want to collect information from the software and have it onto a third-party application. And then the dispatching is where all the interactions between a dispatcher and the radios would take place and have access to all the information. Okay, so also to show you again, so from a conventional system, we can connect via IP. If it's a DMR trunking system, if it's a Hytera system, we can connect via IP. Or if it's an MPT system, if it's a non-Hytera MPT system, we would use a wireless gateway. But because our trunking light system can support hybrid mode, so you can have analog MPT and DMR Tier 3 running on the same infrastructure, you can also connect it like this. Or if it's a Hytera system, you can also then connect it through a IP connection. And then, like I explained before, if you're using the wireless gateway, if this system is a non-Hytera system, or let's say if there's no IP connection from the actual repeater site to the software, you could also use a wireless gateway as long as this mobile radio is going to be in coverage of the actual site. You can then deploy this solution to have access into these radio networks. Okay. Okay, so that's just an image of what the wireless gateway looks like. So you'll see it's got dual Ethernet ports here at the back. It also has 2 inputs for 2 mobile radios, and it also has RS-232 for you to be able to do, get serial connection to it as well. You'll see it's very compact, very small. It's also, you can see it can operate in 0 to 40 degrees. It's very small. If I had to size it, it's about this big. So you can, if it's in a data cabinet, you can actually put 2 of these next to each other on the same rack. And then also it's got an AC/DC power supply that comes with it as well. You'll see in the front here, it's got a display. And this display will show you what radios are online, what radios are not connected. And also you can see from the display, the IP address and all of that. You can also see that it's connecting to the SmartOne server. This is programmed over IP, so you would log into it like you would set up a router, and you can configure all the information on the device through the IP network. Okay, so here's an example. So you've got your SmartOne dispatch connecting and talking to it on IP, and then you've got the actual radios. There's a cable that's connected between the accessory port on the back of the radio to the gateway, and it has full control over this radio, what it needs to do into the network that it needs to talk into. And this is the 12-path gateway, which can support 8 radios. So you see it's got 8 connections here for you to be able to connect 8 different radios or 8 of the same radios. Here you can see it also supports FXO. So this is an analog telephone connection that you can also connect here. It also has a built-in power supply, and then also you'll see it's got Ethernet ports as well. Yeah, also dual Ethernet ports. Okay. And then also it can also take a SIM card as well. Okay, so here's just also some scenarios where you could use our wireless gateway for different applications. So for example, let's say you've got a Hytera system on this end and you've got a different or third-party system on this side. You can also use this wireless gateway and you can connect 2 different radios. So you could put a conventional DMR Tier 2 radio on this end, and let's say if this was a MPT radio, and then inside this gateway, you can then program to say group 10 must talk to group 20 on this side. And you can have up to 30 different groups programmed into this gateway. So if either one of those talk on this end, it will then go to the correct group on this side and vice versa. Just also note that if you only have one radio on this side and this side, if one of those groups are talking and the second group starts talking, it will obviously not go through because the radio is already connected to one of the existing groups. Also, where you can also use this is, let's say if you've got 2 systems and they are not overlapping in coverage, you can deploy two different gateways at two different locations. As long as this one is in coverage of this network and this one is in coverage of this network, you can connect them over an IP network, and then you can then also have the cross communication between the two systems. Here's a different or another scenario where, let's say, if this was a Hytera system and this was also a Hytera system, you could deploy a gateway on this end and this end and use IP connection to link the two systems. And then from the SmartOne, you can then have what we call cross patching. So specific groups here need to talk to specific groups in this side, and the connection will then be established through the SmartOne. Here's a different scenario also where, let's say, the DMR site, there's no IP connection physically to the repeater. You could deploy a wireless gateway. As long as this is in coverage of this network, you can then have air interface to this network. And then this, let's say if there was an IP connection to this system, you can have a IP connection into the software, and it will then form a connection between the two systems. Okay, so I'm going to quickly show you guys what it actually looks like. So you'll see here's all the different systems, and each one has their own separate dispatching softwares. And with SmartOne, you can have a single dispatching software that can talk to all these different networks, either via IP or via a wireless gateway, and it will give you the interconnection between the different systems. Here's an example of what the dispatcher would look like. So you'll see there's different colors. These different colors mean different states. So for example, if a call is being transmitted, it will be in orange. If it's receiving a call, it will be in blue. If there's an emergency, it will be in red. And if it's in hang time or idle, it will be in green. You can also, from the software, you'll see at the top here, it's got these different tabs. You can add more tabs, and for each tab, you can customize it fully. So you can have one tab that specifically just shows you the maps, or you can have one map that can show you the, let's say if you've got CCTV connected to it, you can have CCTV showing on there. It also has a built-in browser, so you can have internet browsing as well. If the dispatcher needs to look for something or information off the internet, they can also do it from the SmartOne client as well. Here's an example of what the map would look like. You can also have a satellite view, or you can have street view. And from here, you can actually see all the radios. You can communicate if there was CCTV connected to the system. You can also, on the map itself, put icons of where the cameras are. And if you had to double click on that icon, it will actually open the video feed for that camera, and you can actually see. So let's say a scenario where there was an incident and you wanted to get visuals and there's a camera close by, you can actually from the map see that there's a camera, and you can open that camera and see the live streaming from that camera, and also have voice communication to the actual radio, or if it's a PTT, or if it's a analog or DMR or Tetra radio. Or you can customize it fully, where you can have some CCTV feeds coming in here. You can have weather and information on here, and your dispatching and voice communications in the center. And then if you have other third-party applications, you can also pull this into the software. And like here's the browser as well. So you can have all of this in a single screen, or you can have it over multiple screens, and then have full control over all these systems from a single dispatcher. Okay, so for example, like here, where when I was presenting on the DMR Tier 3 trunking solution, we also have another software called DWS. So there's two versions of this DWS. You get one for DMR Tier 3 trunking, you get one for DMR Tier 3, for Tetra. If you had to introduce SmartOne could replace both of these packages, because you can have a single platform and you have communication to both of these networks. And you can also do what we call cross patching, where you can have a group here speaking to a group there. This has been a problem for most governments, where your fire department is running off one system and your police is running off a different system, and in some cases they need to be able to communicate with each other. And with this solution, you're able to connect those two groups from two different systems for that time period, and then once the incident has been resolved, you can then disconnect them using the SmartOne. Okay. Let's say for a Tier 2 conventional system, you can't have SmartOne and smart dispatch in the same system. And the reason for this is because when you configure a tier 2 system, you have to tell the repeater the IP address for the gateway. And you can either tell it to connect to the SmartOne gateway or to this smart dispatch gateway. You can't connect to 2 gateways from 2 different locations from the repeater. And that's why you are not able to have smart dispatch and SmartOne on the same network. Okay, and then just to illustrate again, so you would, let's say if you had DMR trunking or conventional or Tetra or LTE or NPT or satellite radio or POC or HF or midband or PSTN for public, all of this can be connected to a single SmartOne platform, giving you unified communication, which will allow for you to have a full-on communication to all these different systems from a single point of view. And this also then gives you the capabilities of connecting a group in one system to a group in a different system, which gives you a more simplified single platform. Meaning you only need to maintain the one platform and not multiple platforms, and having different accounts for the dispatcher to log into different applications to communicate to different systems. So here's an example again where different systems communicating on different levels, and you want them all to be in a single platform. This is just some information of how you would normally configure it. Once you buy the equipment and you start with the configuration, you would log into the IP address of the gateway or to the server, and from here you can then basically configure all the information such as the SIP information, the database. If there's a recording server, you can then tell the SmartOne where it needs to send the recordings to. You can also, for your licenses, you would load it there. But yeah, this is typically the login screen for you to set up the system. So it's very user-friendly, very easy to configure. It doesn't take a lot to do this. As long as you know what you need to put in here, it's quite easy to configure. Okay. Also just some other highlights. So it also supports a hot standby, meaning you can have redundancy. So you can have a primary SmartOne server doing the processing, but you can also have a backup server so that if the one had to fail, the second one can take over. You can also have geo redundancy, meaning at one location you have the primary, at a different location you have the backup. And then also it's open to API, meaning you can third-party applications connecting to it or pulling information out of the software. And then also it's got advanced voice process technology, meaning it can also you can also like have the cross-patch capabilities, voice detect technology, gain control technology. All of this can be configured in the actual software. Okay, so another application, we've got tier 2 and tier 3. So for example, here's a tier 3 trunking system. These radios move out of this area and they move into the tier 2 network. They can automatically switch between the 2 systems with the same radio and still have communication across the 2 systems. Okay, this could be a good requirement, let's say for a customer that has a high density area and they need trunking because there's a lot of traffic, but when they move out of the high traffic area and don't want to invest in tier 3 trunking, if there's not going to be a lot of traffic, you can sell them a solution where they've got trunking in busy areas and tier 2 conventional in a different area, and then use the SmartOne as the connection between the 2 systems, so that if a subscriber moves from a busy area to a less busy area, they can connect to a tier 2 system and still have communication back to a tier 3 group or to a tier 3 radio. So you can also then have cost reduction, not needing to deploy a national tier 3 trunking system, but you can have a blend between tier 2 and tier 3, and then using the professional unified communication SmartOne software to establish the connection between the 2 systems. Again, just some illustrations. So here's a radio, is registered on the tier 3 network. He does a private call to this radio. He can do it on the existing tier 3 system. If this radio moves and goes into the tier 2 system, you can still do a communication private call from the one radio in the tier 3 system, which will then go through to the tier 2 system to that specific radio. Okay. Same for a group call. You've got a group call that's working on the, sorry, go one back. So you've got a group in the tier 3 system, and you've got a group in the tier 2 system, and you want these two groups to be a single group. You can then also use the SmartOne gateway to connect these two different groups to be able to do inter-group calls between the two different systems. Here's another application where you could use a wireless gateway where you can connect a Tetra radio on the one side and a DMR on the other end, and then the Tetra radios can then communicate, and this radio will receive that communication, and it will then send that same communication through to a DMR network. Or you could have the 12-way gateway, which can support 8 different radios. This can be deployed in a mobile unit like this, where you would have different radios connected to this gateway, like a Tetra, a DMR, or satellite, or HF. And all of these different radios will have a connection into this SmartOne, and the dispatcher then can communicate to these different systems, and then also be able to cross-patch the different groups from different systems to each other. This is a nice solution, I think, especially for rapid deployments or emergency disasters, where you have 2 different systems with 2 different groups or people working on the 2 different systems, and you go and park this vehicle there, and this vehicle will then act as the bridge between the 2 different systems for these different groups to be able to communicate to each other. And you can also then have, let's say, satellite, if you wanted to have internet connection, for you to be able to access it from a remote location as well. So again, typically you would find this problem where the police, let's say, invested in Tetra or DMR, the ambulance services invested in conventional, and let's say the fire invested in Tetra. Now there's an incident where these 3 need to communicate with each other. Previously, this was a big challenge because different radios can't talk to the different networks. If you had to use SmartOne, you would then have the interconnection for them to have communication with each other through different technologies. We also have a calling center option where you could have one button and it can dispatch to all these different systems from a single point of view. Okay, so here's just some stats. This has also, these are not the latest stats. I think if I remember correctly, some of these, like this, has increased. So this SAP is a service application where like every system that you connect has a SAP. So this has increased. I think you can do up to 500 here. GPS capacity, I think this is also increased now to 1,500 GPS locations that can be collected in a single second. Call monitoring, this is also increased. I think this can do 250 calls that you can monitor at a single point in time. A number of clients, this is also increased. This is how many clients that can log into the actual server. And then just some performance. So depending on your network, obviously you would want a low latency network to have a more quick response in communication. And then for every voice channel, you need about 80 kilobits of bandwidth. So it's not big bandwidth needed. And then this is just some functionality between intersystems. So you can do group calls, group messages, and it's supported by all of this. If you're using a wireless gateway, because then the network that you're communicating to is not a Hytera system, you are also limited with some because you don't have actual IP connection to the system. So mostly voice and data messaging and some GPS can work through the gateway. And then just some functionalities that you can get from the dispatcher. So you have private call, group call, emergency call, priority call, broadcast, all call. Ambient listening is if you want to remotely open the microphone and listen to what the radio is saying. It also supports call queuing. This is a function on the tier 3 trunking system as well. You can do conference calls, simulcast calls. All of these calls are supported from the SmartOne dispatcher. And that's it from me for the SmartOne. Is there any questions anyone has or wants me to go through again or discuss again? You are welcome to ask, even if it's for anything on any of the previous sessions we've had. It's now the time to ask any questions. So can you guys still hear me?
I'll answer and say yes.
Okay. Do you have any questions, Chad, or Teshin, or Joe, or Lily, or Hein, or Kenny? Let me just see, there's messages that came through. Okay. So is there any questions anyone has?
No question yet from my side, Franco, but I've been taking notes. Once I come across one, I'll send them through.
Okay, so yeah, so the purpose of this SmartOne is if you ever have a customer that invested in a specific system or technology and they want to change or want to keep the existing and move to or introduce a new technology or new system, you could also sell them the SmartOne, which can then allow for you to still have connection from the new system to the existing system. So it's a very powerful system. I can give you guys some references where we've deployed it before. A good example was there was a customer, it's an airline, and this specific airline had to use different technologies because different departments were using different radios, or for example, they were using MPT radios for their ground people. They were using airband radios for the pilots and the planes. They were using Tetra radios to speak to the actual airport staff. And then also, because they needed to communicate to all these different people at sometimes at the same time, it meant that they had to have a MPT radio, they had to have a Tetra radio, they had to have an airband radio. And it was becoming a challenge because you know, having different radios, and then sometimes you needed to communicate from what was coming from the pilot to the people on the ground. They had to you know, do the communication manually between the two, where now with the SmartOne that was introduced to them, they could connect the pilot directly to the person on the ground so that the pilot can directly communicate with that person and not needing to convey the message between the two. Or let's say if the pilot needed to speak to someone from the actual airport, they could do it that way. Or if an engineer needed to speak to the pilot, all of that is now possible with SmartOne. So that's one of the scenarios where we solved the solution. And we connected airband to it. We've connected Tetra, MPT, DMR. So all of these different systems can now talk to each other. Okay, I see there's Hein says, thanks. We might use the link digital to midband soon. Okay, that's fine. Thanks. All right, so if there's any questions anyone has after this session, you're also welcome to email me. I can gladly share this presentation with you guys. And then also, if there's any requirements, please feel free to contact us or make contact with us. We will gladly assist you or help you with the correct solution for the requirements that you have. So thank you so much, everyone, for joining today. And thank you for participating in these sessions. We appreciate your interest and the support that you've given us over the past few months and years. And we are looking forward to future business as well. Okay, thank you, everyone. Have a good Thursday and a good week. Okay, bye-bye.
Thanks, Renko. Cheers.